In this video, I'm going to talk about the lab which is based on Kepler's third law. So before you start the lab, there are pre-lab questions which you must answer. The first question is, what is the Kepler's third law of planetary motion? Write down the equation and explain each term. I have answered here for your understanding in my own words, and you should be able to answer, or you must answer in your own words. So, what is it? So, the Kepler's third law tells you that the square of the orbital period, this is the orbital period, this p square here is the orbital period, and the unit is in years, and a is the semi major axis, or we can call the average distance between the the sun or the planet here. And it can be true for any planetary motion. For simplicity, I have assumed all the planets are moving around the sun, so I have taken sun as the central system and all other planets are moving around it. Okay, so the p square, which is the orbital period which is measured in years, and a is the semi major axis, or the average distance between the sun and the planet, and it must be measured in astronomical units here, AU. And what is the astronomical unit here? The astronomical unit is the distance between the Earth and the Sun, that we call as an astronomical units here. Okay, and I have already recorded the video which explains in details about the astronomical units. What is the value in meters? So you should be able to get the information from the videos. Okay, so let me explain the Kepler's law one more time here. So you see, this is the sun, that's the sun here, and all other planets here. All other planets are moving around it. Okay, so you remember the equation that tells you p squared is equal to aq. So what does this mean? A is the average distance between the sun and the planet. Now let's say this is the Earth and this is the Saturn here. The more the distance here is, the orbital period should be greater. The p square is equal to a cube here. So now I see here the Earth. Now if I compare the Earth and the Saturn, which has more, which has the greater distance? Of course, the distance between the sun and the Saturn is greater compared to the distance between the Earth and the sun. So that means the orbital period of the Saturn must be greater than the orbital period of the Earth. And what is the orbital period again? How long does it take, or how many years it takes to complete one orbit around the sun? That is the orbital period. For the orbital period of the Saturn would be how many years it takes for the Saturn to complete one complete orbit about the sun. Okay, so when you use the Kepler's third law, or when you use this equation here, then this must be in years, this must be in years, and a must be in astronomical units here. Okay, so this is in, oops, let me use a different color here sometimes. Okay, it's not letting me write down. Okay, and now the other questions are here. Let me go to the second question here. So in this problem, you have given the distance between the planet. The planet Jupiter is about 5.2 AU. AU stands for the astronomical units. And then based on the Kepler's third law, calculate the orbital period in years. So how do you do that? So I'm going to show you here. We remember this equation, p squared is equal to, oops, p squared is equal to a cube. So that is the equation here. You remember this equation here. And now A is given, which is 5.2 astronomical units here, P square. And do the math. And from this one, you should be find out this number here. And then whatever the number you get, because this is a square, you have to take the square root. And then you'll get a certain number, and that certain number will be the answer, and the unit must be in years. Okay, so that's how you solve it. And the same way for the problem number 3, I'm going to delete this one now, and I'm doing for the problem number 3. What does it tell you is the Saturn tour takes approximately 29.5 years. So again, use the same equation, P squared is equal to AQ. And we're going to solve for the A. So AQ, P value is given, that is the orbital period in years, so 29.5, and you must square it. And when you square it, then you'll get a certain number here. And remember, this is in years. So when you get this number, then because this is a cube, whatever the number you get, then you have to do 1/3 of this one. And when you solve, you will again get a number, and that must be in astronomical unit AU. So that's how you solve it. Okay, so make sure that you know how to plug these numbers, take the square root, cube, 1 over cube in your calculator. You must be familiar with these things. Now I have provided you a table here. So in this table, you see the orbital period of all the planets that moves about the sun is given. For the Mercury, Venus, and that is the period, and this is in years, and this is the distance, which is in astronomical units. For all the planets is given here. So the next thing you have to do is fill out this table here. You have to find out P squared and the AQ. What is P here? The P means you have to square this number here. And I'm going to show you one example, and I'm going to use the Excel, and from there you should be able to do the rest. Let me copy. I simply copied this one, and I'm going to paste here. Okay. So I have Mercury, and then I come over to this cell here, simply click is equal to, make a little bigger here. Now let me do a little bigger here so that you can see. Okay, and now come back here again, put is equal to and a square. So a square, simply you see I did this way, P square, and then click over here again and simply double click, and then you'll see P square. And exactly in order to get AQ, I come to this point, this is A and IQ, you see, and then press enter, come on this cell and double click here. That's how you get this one. And then you simply copy this number here. You can simply copy P square, or let me copy this one. You can copy this one, Control C, and paste it here, or you can manually type all the number here. Okay, you have to do manually probably. All right, so once you have this one number, then you have to plot a graph of P square and AQ in Excel, and let me show you how to do it. So this is P square and AQ, and we have to plot a graph. So I selected these two columns, go to insert, and go to the scatter diagram and come over here. Okay, and that's the P square AQ, and then go to here and access titles and write down the titles here. What is this one? This is P square and you can write down P is equal to orbital period. And the same way here, and this is AQ, and where A is equal to average the distance between the Earth and the Sun. Between Earth and the planet. Oh, sorry, between the Sun and the planet. That's how you write it down. And then you can name the name of this graph here. You can write down the Kepler's third law. Kepler's third law. Okay, so that's how you plot the graph here. And then what is the question asking here? So you plot a graph, make sure that you label your axis. So okay, you do it, and now plot the graph of first 4 points. And why first 4 points? Because if you look at the P here, it goes from 0 to 25,000, but there are many points here which are in this area here, and we're not able to see it. So what I'm going to do, I'm just selecting the first 4 points here. Okay, just selecting these 4 points. So I'm going to plot the few points which are scattered in this region, and do the same thing. Scatter, go over here, and that is the plot here. And now you have to label these axes again. What is along x-axis, what is along y-axis? Make sure that you write down you label the axes. Okay, so go back to the question one more time. Plot a graph of last 4 points. So let's do this one again. So I'm selecting these last points here. Insert. So this is the so I'm simply selecting the last 4 points. Go back here. If it's not allowing, then I have other way. I can simply select these 4 points here. Control C, Control V, and just put as a number here, and then select these 4 points and come back here. Insert. Okay, so now these are the last 4 points. 1, 2, 3, 4. Okay, so that's how you plot the all your data here. Now what is the question asking? What is the trend line? So you have to find out the trend line. And how do we do that? So let's see how do we do that. So now let's say I'm coming to this one. Go back to the add button here, and you see the trend line. Simply click on the trend line, come back here again and go to the more option, and then make sure that it is linearly selected, and then display equation. So display equation. Okay, if you come here, then you'll see equation here. That's the equation of the graph. And what is this equation telling you? If you look carefully, I want to make a little bigger. So I can still read this one. So this equation tells you that the P square versus AQ is a straight line. So it clearly, it's very well fits the hypothesis that P square, which is the orbital period, is equal to the AQ, which is the cube of the average distance between the sun and the planet. So it very much follows the Kepler's third law. And this is the equation. That's the equation here. All right, now let me see if there is any other questions. And exactly the same way I fit the line here, you should be able to find out the equation for this one too, or fit a trend line. Go to the trend line and then go to the more option. Make sure that you select the display equation. That's how you get it. Okay, So what's the outcome of this learning, this activity is that the orbital period, the square of the orbital period is equal to the cube of the average distance between the sun and the planet. So it very much verifies the Kepler's third law. So go through this one, this lab manual, and make sure that you understand, you know how to mathematically calculate all these numbers, you know the equations, and if you have any question, any confusion, feel free to ask me. So this is it from this video. If you have any question, reach out to me. Thank you very much. Bye bye, have a wonderful time.